In this section, I'm going to talk about best path selection process in BGP, and we are going to talk about some attributes, and the first attribute that I'm going to talk about is weight attribute. The weight attribute can be applied to routers in two different ways. First of all, you should know that weight attribute is a local attribute, so it is not advertised to other routers. So if I set weight for a route or for a router on router 1, this is not going to be advertised to router 2 or router 3. Router 2 and router 3 do not care about the weights that are set on my router, on me. Okay, so I can apply this in two different ways. I can apply a weight to a neighbor, or I can apply a weight to the routes that I receive from a neighbor. So if I apply a weight to a neighbor, all routes from that neighbor are going to receive the weight attribute on me, of course, here. And if I apply weight attributes to the routes that I receive from a neighbor, I can select some routes and apply weight to those routes and leave the other routes alone. So this is two different ways. In my topology, as you can see, I have two exit points from my enterprise to ISP. This is my exit points. One from router 2 to I2, one from router 3 to I3. You can see that I have two connections to the same ISP. And this is because I'm going to show you some attribute from, for the entering routes that I have, I can set on my routers. And of course, you can have multiple connections to multiple ISPs, and I'm going to show you that kind of configuration later. But here you can see that I have two exit points from my network, and this is the most important part here, the exit points. So if I issue a packet from router 1 to some, for example, some network here that is connected to this router or other routers that are representing internet here, I can send it using router 2 or router 3. But I may have some preference over selecting these exit points. For example, I may want to send some packets to a specific network in internet using router 2. Or I can prefer router 3 over router 2 for some other networks. So this is where I will go for best path selection, or I can manipulate those best paths, and I'm going to show you how. So let's first go for weight attribute. Assuming that I have received some routes from internet, I prefer to reach to those routes from router 2 unless router 2 is out of service for some unspecified reason. So how can I do that? If I want to set this using a local attribute, I will go for weight attribute, and the weight attribute is going to work like this. On router 1, I can set weight for a neighbor, or I can set weight for some routes that I receive from neighbor, and I'm going to show you both of these. First of all, I should say that the link between router 2 and I2 is not advertised to my IGP in my enterprise, and of course it is not advertised to ISP's IGP2. So we have two different approaches to solve this accessibility problem. And you know that one of them is to change the next hop to self, and the other one is to advertise this link into IGP, and this is up to you to choose this. In previous section, I believe that I have advertised this link into IGP, so in this section I'm going to change the next hop to myself. So on router 2, whatever I send to router 1, I'm going to change its next hop, and I am router 3, of course, and the same should happen on I2 and I3 for the ISP routers. So let's go to router 2 first of all. Let's go to router 1. First of all, I want to show Ip Bgp Table. As you can see, I have received all routes from the ISP, but the problem is they are not best path because they are inaccessible. So if I want to show one of these in particular, you can see that this is inaccessible, and this is due to the next hop problem. So if I go to router 2 and type neighbor 110.1.1.1 and change the next hop to myself and clear Ip Bgp neighbor softly, and I want to do the same thing on router 3. So router 3 is going to have such thing. If I go to router 1 and check this, this is no longer inaccessible. Of course, you can see a metric instead of the inaccessible thing here. So for I1, if I show Ip Bgp, the same problem exists. You can see that this is not accessible. That's because the next hop is inaccessible. So if I try to check this, it says it is inaccessible due to next hop problem. So if I go to I2 and for this change the next hop to myself, and I should do the same thing on router 3. Of course, the IP address is a little different here. If I go back to router 1 and clear Ip Bgp softly and check this again, this is going to be solved like this. Okay, let's go to router 1. First of all, I want to check how I'm going to reach to this network. So if I do a trace route and source it from my loopback 0, that's because my loopback 0 is the only thing that is advertised to BGP, so the other routers in ISP can reach to that. You can see that it goes through router 2. It goes through router 2, so I'm going to change this behavior. I want to make sure that router 2 is not the exit points. I want to make sure that router 3 is selected over router 2 in any circumstances. For this I'm going to set a wait for my neighbor. So I type neighbor 110.333, that is router 3. I'm going to set a wait of, for example, 50,000. And you know that wait attribute is a 16-bit attribute. So a 16-bit attribute can be up to 65,000 in decimal. And now I have set this. So let's clear Ip Bgp any softly. And now I'm going to repeat the trace. And this time you can see that router 3 is selected over router 2. And that's because it has a better weight. So if I go to this, show Ip Bgp for this specific route, you can see that it says there's a metric that is quite the same in both, but here I have a weight of 50,000. Here I don't have a weight, and this means a weight of 50,000 is better than having no weight. And you know that having no weight sometimes is interpreted in having a weight of 32,000, I guess. Okay, and I'm going to remove this attribute from router 1 for this neighbor. You know that I can, whenever I assign a weight attribute to a router, all routes from that router are going to receive this weight. So if I show Ip Bgp here, you can see that routes received from router 3 all receive a weight of 50,000, but the others have no weight, or the weight is set to 0. And of course, as I told you, the default route is 32,000 for the routes that I have initiated. Okay, this time I'm going to remove this. So I type no neighbor 110.333, weight of 50,000. For some specific reason, I just want to set weight to one or two of these routes. For this, I need a route map. And to match this, I can use a prefix list, and that is, I guess, the best thing, because a prefix list can be used to match specific routes here. IP prefix list, for example, network 50. For sequence 5, I'm going to permit 50, 50, 50, 50 slash 32, and that is the only thing that I'm going to match. So I create a route map, and the name of this route map can be the same as the name of the prefix list. These are not going to collide. And permit 10. I'm going to match IP address prefix net 50, and I'm going to set weight for that. The weight is going to be 50,000. But for the other routes, I'm not going to do anything. They are going to be untouched. Okay, so now I need to go to router BGP process, and I'm going to add this to router 3. That's because I'm going to assign this weight to the route that I am receiving from router 3. So 110.333, I'm going to assign a route map to that, and that route map is net 50 and inbound. Now clear Ip Bgp neighbors, and now if I try Ip Bgp table, you can see that all routes have default weight except this one that I have assigned the weight to that. So if I try to trace to 50, 50, 50, 50, and source it from my loopback 0, you can see that it goes through router 3 and exits through router 3. But if I try other networks, I don't know which way it is going to select. Perhaps router 2 or router 3 based on the IGP or other base path selection attributes that we are going to talk about later. So this is how we set weight on our routers.